Hey guys, welcome back. And to this, our second and last lecture on PLSQL functions. In particular, in this lecture, we are going to create a function which accepts the current NFL game conditions and returns its predicted next best play. Now, a word of caution here. Guys, this is an exercise that was created, or as an example that was created because it met my learning objectives, not that it's going to solve the world's NFL problems. Okay, so don't take this code too serious. It's here because it meets our learning objectives. More to the point with respect to what we're going to cover in this lecture, we are going to look at user-defined, i.e. complex types being input and returned from functions, how to debug under those kinds of conditions. We're then going to look at random number generation within a specified range, the use of dynamic SQL, very powerful tool, and then random number weighting. That is, we are going to do some weighting on top of random number generation, which is kind of a cool thing. And then we're going to also finally discuss the value and sometimes the need for subject matter experts to augment our skills when we're covering things we really don't know what we're talking about. In my case, I'm not a real strong statistician, so when I get into an area of stats that I'm not very comfortable with, I go to some of my colleagues and say, hey, please help me out here. So those are going to be the things we're going to cover. This is lecture 12, so let's open up the script and jump inside this code and learn. Time to learn something. See you on the inside.
Okay, let's start at the very top with the signature for this function. Looks like this guy's going to accept a user-defined type named prev_play for previous play, which is made up of the fields currently contained within the game plays table. Yeah, I guess that makes sense. If we're going to predict the next play, it makes sense that we know what's going on in the game right now. Also, looks like this function returns a variable of a type similar to a row in the team plays table. Now again, that makes sense. This is the play we're suggesting happens next. But wait a minute. Do we really want to use our IDE debugger for this guy if we have to set up all these variables? I mean, that's a lot of stuff. Well, if you're me, the answer is no. If I were ever to try to set up all those variables and get them synced up, I'd almost certainly mess it up. So what do? I write a little parent calling procedure. Here's an image of my little tester routine. Now I know my this game play variable is going to be correct and not inconsistent across column values. Pass that guy into pick next play function and we're ready to start debugging. One note, however, both routines must be compiled for debug for this technique to work. Okay, enough on that. Let's move on. All right, we then begin by declaring a local type named local possible plays, which is a table of team play rows and again indexed by an integer. We instantiate that type with the variable possible plays and index that array with the possible plays count variable. Okay, very straightforward. Nothing new now in the declaration section until we get down here to the my dynamic SQL variable and its associated reference cursor. Here's how this game is going to play. We will build our my dynamic SQL select statement based on changes to the my criterion variable. We'll then open the myref cursor with the my dynamic SQL string and ultimately then fetch instances of the results into the specific team play type. Very cool technique and also very powerful. We'll check it out completely down below, so hang in there when we get down into that section of the body. Finally, down here at the bottom of our declarations section, we have a function declaration named normDist. This guy accepts a z-score and returns the cumulative area under the normal curve for that z-score value. Hey guys, I did not write this one. I got it off the internet. But what's our rule about code off the internet? Assume it's wrong. Well, I did exactly that. As you can see, I knew how to take this exact same calculation in Excel. So I compared those results to the results I got from this routine. Ta-da! The author was from Penn State, and apparently at Penn State they know their stats. What do you do if you don't even know enough to validate an internet routine? Well, my suggestion is you find a subject matter expert and ask that individual to help you validate that routine. SMEs are your friends. If you need them, then use them, but never assume someone else's software is correct. Good news for us, the person's code was dead on target. Alrighty, let's move on to the body of our code. We begin by randomly selecting a play on first down. What's the learning objective? Well, of course, it's generate a random number and then learn how to restrict it given a specific range. Let's take a look. We begin by testing for a first down condition. Once we identify that, the next play will be a first down. We determine whether our team is offense or defense. Fine, with that setup stuff out of the way, we're now able to loop through the cursor we defined up above in the declarations section and add our rows to the local possible plays array, indexing that guy with the possible plays count value. Easy enough. The next is pretty cool stuff. Here we're generating a random number with a user-supplied PLSQL package. We then do modular arithmetic on that guy to restrict it to a range of 0 through our possible play count variable -1. We finally bring that whole thing back into our table index range by adding a 1. Ta-da! Random number within a specified range. Another learning objective knocked out. End first down logic by returning the selected row from our local possible plays table, and we're out of here. Okay, time now to move on to the second down logic. Check this out. We're starting by building a string variable which contains the bones for a standard select statement. Using our if statement, we then concatenate more where clause logic to this string based on the yards to gain variable. Oh my, how cool is this? Sliding down the code, we then use this dynamic SQL string to open our previously defined reference 3 bind variables. Set up a loop which steps through the returned rows and stores them to our local table array, again using the possible play count variable as our index. Now people, I know I just went through that stuff really fast, but please take your time and study those couple of paragraphs of code because reference cursors and dynamic SQL make a very cool and powerful combination. By the way, your dynamic SQL does not have to be a select statement. You can build dynamic insert, update, and delete statements as well. Heck, you can even build dynamic DDL statements and execute those guys immediately if you have the appropriate privs. As a matter of fact, I once wrote a set of routines which read a user-supplied set of specifications and built the corresponding schema appropriate to those specs. Now granted, the scope of the schema variations was relatively small, but it was still pretty cool to be able to read an input specification and generate an entire script to be run to create a new production database schema. Yep, dynamic SQL is your friend. However, before we move on, a quick word of caution on the use of dynamic SQL. Please always use those bind variables. Do not recreate the entire dynamic SQL string embedding your literals. The reason is because the optimizer needs to generate a new plan each time it's executed if you build those variables in versus if you use a bind variable, then the optimizer can use a previously executed plan. A big performance difference, just a note of caution. All right, moving on down to the third down logic. As the comment describes, on third down, we're going to do a weighted random selection of our next play based on the play's previous success. That is the play's associated consistency measure. Now, calculating this consistency measure, we have to wait until our first package lecture. But for now, suffice it to say that this value is represented as a z-score equivalent. For those not familiar with a z-score, it is the number of standard deviations above or below the mean as associated with a specific point on a normal curve. Anyway, to convert a z-score back into a 0 to 100 scale, you take the value's normal distribution function as described above, multiply that guy by 100, and then round the value. Cool enough, and that's exactly what we've done here, of course. Note how we use the normal dist value to weight our possible plays table with the number of corresponding entries. That's elegant code, guys. That's a reasonable way to weight things. Again, I went through this section pretty fast, but suffice it to say that the learning objective was how to build a weighted random number generator. All right, and finally we have the code for fourth down. Those of you familiar with American football also know that fourth downs are pretty boring because they're almost 100% predictable. Well, so is our code here, so please just check it out quickly, but also nothing really interesting going on here. We've already covered all our learning objectives, so our job here is done. I'll catch you on the outside.
All right, welcome back, and I hope you had some fun on that code. I know there was a lot of density there, and don't worry about it if you didn't quite keep up. Just take your time, go through that code again, and as I've mentioned before, I still think the best way to learn this stuff is to close the resource materials and actually attempt to recreate that code on your own. Make the mistakes and fumble through the syntax until you've got it down cold. So what did we learn in our pick next play function? Well, we first learned about managing complex user types with respect to both returning input as well as debugging under that situation. Not a trivial situation. One of the cool things we did handle in this code is we used a local indexed table based on a row type. That was cool. We generated some random numbers within a specified range. We then looked at dynamic SQL. We looked at weighted random numbers, and finally we talked about the need for subject matter experts. All important stuff, guys. I know this is real world stuff because I lived it for a long time. So please take your time. Make sure you understand each of the elements of this code, because once you get out there and you start coding, you're going to be using this stuff on a daily basis. Cool beans. All right, that concludes this lecture. In our next one, we are going to take a look at packages. Finally going to start playing with the real big boys, because that's where you'll spend most of your coding time. You don't want to expose every procedure and function to the world. You want to limit the footprint available to users. In addition, you want to be able to overload functions and procedures and make different signatures available to our programming community. So that'll be great fun. We'll see on the inside of Lecture 13. And in the interim, you know the gig. You go out there and you have some fun, but learn something new every day, because it's what's important. Catch you later, guys.